Good morning and welcome to EE391, MM391. We are on week 10, lecture 3. Today is the 29th of October. Welcome to this morning's lecture session for engineering economics. By the way, can you hear me and see me, Hafiz and Bavish? Are you guys here? Can you guys hear me and see me?
Yes, sir.
Okay. All right. Thank you. All right. All right. So let's continue with our lectures. Let's continue with our lectures and where we left off. All right. Okay. And I hope you are aware of the particular rules with regards to our our assignment. We will be the upload link is ready for week 9. Week 9 lectures upload link is ready, and as soon as you guys are have your lectures ready for week 9, you can go ahead. For week 10, remember, you can start to get some exemptions. There were no exemptions in week 9, but there are exemptions in week 10. Okay, starting with lecture 2 and lecture 3 onwards. All right, lecture 2 onwards. Okay, let me share the screen, guys. Let me share the screen. Okay. Okay, guys, can you see me? Can you see my Microsoft Word document? Hafiz and Bavish, can you confirm if you can see my Microsoft Word document?
So only the desktop is viewing.
Okay, that means the wrong screen is shared. Hang on. Let me share it again. Let me share it again.
Yes, sir. No.
Okay, nice. Thank you. Thank you. All right. Okay. So let's do a quick revision of what we were doing when we left off. We were looking at this particular problem whereby where a investor had given some an investor had given some funds, and basically we were trying to find out, we were trying to do comparison. This particular topic is known as comparison, and we were basically trying to investigate what whether this particular deal would be good, right? So a particular contract was being sold for $6,800, right? In which there would be $140 what do you call revenue at the end of each month for a 5-year period. Now, the way to calculate it, a lot of students would just go and say, hey, what we do is 140 times 12 months times 5 years, and we will get the answer whether 6,800 is worth it or not. But remember, you've got to take into account that there is a 1% interest rate. So we've got to now do a comparison. We do the cash flow diagram here, right? We do the cash flow diagram. Then we found that using P given A, the value comes to $6,293. And because this is lesser, since this is lesser than 6,800, remember you spent 6,800 for this contract. We now know that this is not a good investment. You pay 6,800 to get this particular business going, where your tools will be lent out and you receive $140 per month. But taking into account a 1% interest rate, you realize that, hey, we won't be able to recuperate our 1,800, right? So our 6,800 will not be recuperated. Right? Therefore, this is not it will not be recuperated. Therefore, this is not a good investment. So what we do, we reject the offer. All right, let's move on to today's lecture. Let's have a look at another problem. The way we are running the lectures, guys, the way we are running the lectures is basically we'll be doing lots and lots of problems. You know, this particular engineering economics is very heavy on the particular economics aspects. Okay, very heavy on the analytical aspects. Okay, all right. Now, before we move on, guys, can you please, for the purpose of our exemptions, can you please enter your student name and ID number into the chat box? Can you please enter your name, full name, and yeah, okay. So 2 people are there already. Right, please do that, okay? Tabake, your full student number did not come up, okay? Okay, all right. I'm going to move on with the lecture while you guys do your thing. Guys, okay, so Tavake is saying, how will we know that if you are eligible for the exemptions? What I will do is the TAs will announce it, but also these chat transcripts, I will place them in the Moodle shell, so you can just go and count the number of times you put it on there. But in the meantime, one of the TAs will be very quick in getting the in relaying this the number of exemptions. Okay. Who is exempted or not, all right, for that particular week. But right now, remember, we are only doing week 9. Week 9 is due this next week, Tuesday, and then week 10 is due a bit after that, all right? Okay, I'll get more to that soon, all right? I'll make announcements. Okay, a student is borrowing $6,500 per year. A student is borrowing $6,500 per year, okay? So they are borrowing $6,500 per year, all right, in order to pay her university tuition fees. The loan will be repaid 2 years after the student has completed her 3-year degree. Her 3-year, okay, we can say bachelor's degree, all right, okay. The interest rate is fixed at 15%. 15% per, okay, when we say 15%, we always assume it's per annum. Compute how much will have to be repaid, right? Okay, all right. Now, you see the degree. Oh man, this, it shouldn't be saying $100, right? Let me just correct that. That should not be saying $100. That should be saying $6,500. Can you correct that cash flow diagram? I've got the cash flow diagram here, but it's incorrect. So $6,500 per year for 3 years. All right, okay, and at the end, so let me just get rid of this thing here in order to avoid confusing you guys. The cash flow diagram I need, right, even though it's incorrect. Okay, now $6,500 per year, right, and after the end of the degree, which takes 3 years, just like a normal bachelor's degree, right, 2 years of a holiday, 2 years of a loan holiday, followed by repayment. You know, in this question we just assume that the repayment will start immediately, right? But in reality, the student will repay over 6 or 7 years. All right. So just note that should not be cash flow diagram should show 6,500 per annum. All right, and also I just want to correct this interest rate. The interest rate should be, guys, around about 8.5%. More realistic, make it 6.5%. All right, 6.5%. All right, now, how do we calculate this, guys? How do we calculate this? Well, what we have here is, you see this $6,500 in the first instance, right? This $6,500 will, right, we've got to find the future value from the first year, then we've got to find the future value from the second year, then we've got to find the future value from the third year. So the final amount, future value, will equal to F1 plus F2 plus F3, whereby F1 and F2 and F3 are from each of the years, all right? Okay, now, what is F1, guys? F1, how do we calculate F1? What formula do we use here? What formula do we use to calculate F1? Anyone? Let's see your chat box. Put your answer in. What formula? Which particular... What do we use? F given A? No, this will not be F given A. Guys, this will not be F given A. Remember, F1 is the value of this $6,500. The value of this $6,500. Let me just play some more bit about over here. Okay, the value of this first $6,500, right? Remember, okay, this is the catch, Amit and Rerario. When you use annuity, when you use F given A, the catch is that the A continues all the way till the final year. All right? If you wanted to use F given A, the A would have continued all the way till the final year. All right, so let's see. What is our knowns? What is our knowns? Our knowns are, okay, you have $6,500 for years 1, 2, 3, and then $0 for years 4 and 5. All right, and $0 for years 4 and 5. Okay, now, and we have to calculate, and we know that our interest rate is equal to 6.5%. Now, when you use annuity, the assumption over here, when we use annuity, the assumption over here is that annuity continues all the way till year 4 and year 5 as well. That's the catch. Okay, so let me put a note here. Okay, notes. Sorry guys, let me just when we use annuity, annuity requires that the amount is either deposited or received. It can be either way. Annuity can be pointing upwards or it can be pointing downwards. All right. It requires that it should be deposited or received on every interval all the way to the end, except for interval 0. Right? Obviously, annuity does not show on the interval 0, but it should go all the way. There should be arrows on 4 and 5. But in this case, there was no 4 and 5. So let's do this problem, guys. Let's do this problem. Okay. Okay, so that's $6,500 there. All right, now. Okay, so how do we handle this? So what we have to do is we have to find what is the value of this $6,500 projected all the way till year 5? What is the value of the second $6,500, the year 2 $6,500, all projected all the way till the final year? And then find the value of the third $6,500 projected all the way till year 5. All right, and then we sum it up. So that's why we say final value is the F1, which is coming from the first year, plus F2, which is coming from second year, plus F3. So now my question is, how do we calculate F1, future value of 1? Yes, so what formula is good Tabake, you have given the formula. So Tabake, you are slightly incorrect. You have given the formula. Yeah, Lufkesh, you're right. So that is the formula. But what do we call that, guys? I want you to tell me in terms of the value. I mean, in terms of the type of formula, the name of the formula. You have to use. What do you have to use, guys? What do you have to use? F given P, right? F given P. Don't worry, I'll put this. F given P. Okay. F given P. Alright, so F given P, so F1 will equal to that times P1. Alright, now let's now go ahead and do this. So F1, what is F1, guys? I mean, yeah, what is P1? P1 multiplied by, right, F given P. So Josiah is the only one who got it right. Guys, you guys are not putting in solutions today, I notice. That's okay. Well, all right. And to the power of n. Okay. Okay. Right. What do we get, guys? P1 is what? 6,500, right? And 1 plus I. What is our I? I is 0.085. And what is our n, guys? For P1, for F1. Listen to this. Listen to this. Tavake, you are very good. I like that you are involved in this course. See, it says the interest rate is fixed. This is the key catch over here, and this is a real life scenario. The interest rate is fixed at 6.5%. So what does that mean? That means that the interest rate is fixed, but does not mean that you go switch to simple interest or compound interest. It will still be compound. We always deal with compound interest. Unless otherwise stated, unless the question actually states to use simple interest, then you use simple interest, right? Otherwise, it'll always be compound interest. But in real life, what happens, Tabaki? You've got a good question over there. What happens is that this 6.5%, in year 1, the interest rate will be 6.5. In year 2, the interest rate will be 6. In year 3, the interest rate can be 6.2. It fluctuates. In real life, the interest rate will always fluctuate. All right? Okay? In real life, the interest rate always fluctuates. Okay. Now, so to the power of n. Now, tell me, how many years is this thing? How many years is this guy F1? How many years will it compound? How many compounding periods? No. How many compounding periods for the thing borrowed in year 1? Remember, the repayment time is year 5. It'll go for 1, 2, 3, 4. Okay? All right? It'll go for 4 periods. All right? So it'll go for 4 periods. Okay. So what do we get here? What do we get? What do we get? Answer? For F1? Amit? Yeah, right. All right. All right, let's look at F2. Let's look at F2. Right? F2 will be the same thing, but, right, so we just write down the value over here, 8.5%. But what will be the N for F2, guys? What will be the N? Oh, sorry, yes, 0.065. Yes, 6.5%. What will be the N? There will be 3 now. Okay, it will be 3. So P2, 6500, 0.065. And what do we get? What do we get, guys? 7,000 this time. Okay, so 7,000. Now let's do F3. The only thing which changes now for F3 is that 2 years, right? It's 2 years. So what do we get for F3, guys? F3. F3? 2 years, guys. It's now 2 years. Oh, okay. So still 7,000, eh? All right. I didn't pick up that it's still 7,000. So the largest amount of payment was the one which is from the first year. All right. Now, can you give me the final value of F? What is F equal to? This is F1 plus F2 plus F3. What do we get, guys? F1 plus F2 plus F3. Yes. 23,000. There we go. So that is your answer. All right. So that's a real life example, you know, and this will be very helpful for you because you guys are on like a TELS loan scheme. You're on a TELS loan scheme, yeah? So because you're on a loan scheme, now you know what is the interest rate. By the way, what is your interest rate for TELS? For those of you who are on the loan scheme, what is the interest rate? What is your interest rate, guys? 0. Okay, Tabaki, can you repeat your question? You can just say your question online, babe. Tabaki? Sir, the question 6500 just ends in the third year? Yes. So in the question, this person here withdraws 6500 for 3 years, and then after that they graduate, they get a 2-year holiday to look for a job, and then, you know, in the first 2 years they no deductions are done, and then the deductions start in year 5. Okay? All right. Christian, so it's 0%, eh? I thought it was, there is a percentage rate. But if it's 0%, that's really good. That's a really good charity from the government to those of you who are on TELS. Okay. Okay. All right. Let's move on to... we'll discuss it. I will try and find it out. As an exercise, just find out what is the interest rate for TELS. I think it's 0.5% after the first 2 years.
No, sir. It depends on the household income.
Oh, the interest rate changes as well. Okay, okay, nice. That's even better, that means. That's even better. All right, guys. I want you to note over here the method in which I wrote the notation. You see, in the beginning, you write the formula, right? Can you see I write the formula over here? Then after that, inside the formula, I change this. And you don't need to show me the calculation. You can just, from here, jump straight into this. This here gives you a value. Now, in real life, guys, okay, we engineering students, we know how to do computations. Some of those economics guys, they are not so strong in mathematics. So what they do is they actually have these tables. They have these tables and they refer to these tables, right? And there's books and books of tables. So they will go and they'll look under the F given P section, 6.5% and number of years. And then they'll get some figure over here. And then they'll multiply it, all right? Okay, let's move on to the next question, guys. Okay, the next topic is cash flow analysis. Until now, I've been introducing you to some concepts. I've been introducing you to some concepts, but when you are compounding more frequent than your payments, when you are compounding less frequent than your payments, and so forth. I want to now introduce you to certain concepts. Let's now look at some cash flow analysis. This is going to be an easy problem. All right, this will be a very easy problem for you guys. Um, let's now look at this problem number 1. All right. Now let's look at this. Let me just get rid of the equivalence problem, which we will try and start off this morning, and then we'll continue. Right. A company is considering the purchase of a piece of equipment that cost $5,000 and has a life of 5 years. If the interest rate is 8%, how much will the equipment have to save every year in order to recover the initial investment? Right? So this is just another way of looking at a real life example. All right? So what are our knowns? Okay. Firstly, our knowns is that our purchase which is equal to your present value is what? Is 5,000. Right? Okay, good. Then your life, which is basically equal to N, is equals to 5 years. Right? Then your I is equal to 8%. Very simple problem, guys. What do you have to do? You have to find A. We have to find how much will the equipment have to save. So we have to find A, annuity. Right? So what do we use? Which formula will we use? Yes, we will use, right, A given P. Actually, so let's now have a look at this. Let's now draw the cash flow diagram. Just try and draw the cash flow diagram for you guys. Okay, 0, 5, 1, 2, 3, 4. Sorry if it's not so neat, but you understand. Okay, 0, 1, 2, 3, 4, 5. Okay, and the initial value was, there was a purchase made, right? There was a purchase made, right? So that's our present value, which is equal to, how much is that? That's 5K. Present value is 5K, and this machine has got to do savings every year. The machine has got to do savings every year, and the value of that savings, okay, the value of that savings we have to calculate. Okay, all right. Now, you guys already know this. This is A given P, right? You have to find A given P. But the key thing over here, guys, the key requirement is, I'm just going to clear that now. The key requirement for you guys is, if you are given a question like this, the question is not so much about it's I know all of you guys will jump onto the calculation, but what we are looking at, what we will be looking for in your short test and your quizzes and all of that is your cash flow diagram. Somebody can draw the cash flow diagram in the opposite direction. Somebody can draw the cash flow diagram in the opposite direction. All right, they can draw the cash flow diagram in the opposite direction and um, still get the same answer. We are looking at the direction of the arrows and so forth. Okay, all right, now let's now see A given P. Have I done an A given P problem? Find A given. These are all the problems I've got lined up for you guys. Okay, we've got an A given B problem. So the way we write it now, I'm going to be more and more professional, is we're going to write it like this. Right? We have to fill in these areas here. So what is the interest rate, guys? What is the interest rate over here? What is the interest rate? It's 8%. So we write down 8% here. And what is N over here? It's 5. Okay. So this is A given P, 8%, 5 years. Right? And that is the formula. Right? So what we get is the original amount was 5,000, 8%. Right? And the answer, unfortunately, I've done the answer for you. So there will be no exemptions over here. Can you just check if this answer is correct, by the way? Yes, it is correct. Okay, thank you. All right. Now, everyone on board? You see how I'm using the notation here? All right, let's now move on to one heavy-duty problem. Right, this is like the Dune sort of problem. I don't know if you watched the Dune yet or not. Okay, how many of you watched the Dune? Okay, all right. Okay, right. Let's have a look at this new concept called equivalence. This new concept called equivalence. Now, in the following cash flow diagrams, what is the value of C that makes the two cash flow diagrams equivalent? Assuming an interest rate of 12%. All right. Okay. This is a heavy duty problem. This is a heavy duty problem. This is an exam level question because you've got to really think about what's happening over here. Now you see this person here is making $100 repayment, right? In year 1 and year 2, period 1 and period 2. And then he's making $300 repayments in year 3, year 4, and year 5. Now, let's say that was the original plan. Let us say you bought a radio or a television or something, and then that was the plan for you to pay over 5 months or 5 years or something like that, right? Okay. But then, because you had to spend some money, you projected that maybe it's your cousin's wedding, you have to spend some money in year 3, right, or month number 3. Then you said, okay, instead of paying that, I'll pay equivalent amount in year 1 and year 2, and then, or month 1 and month 2, period 1 period 2, and I'll pay equivalent amount in year 4, period 4 and period 5, and I will skip repayment in period number 3. What is the value of that C? What is the value of that? So that is equivalence. In the end, the repayment made should be the same. All right? The repayment made should be the same. All right. Now, let me annotate over here. Let me draw this thing on the whiteboard. Okay, let me draw it on the whiteboard. So, what we have to find, guys, in essence is this. Okay. What we have to find Okay, put this one here as well. All right, nice. I like this. Okay, these are all different things. Okay, so the end, what we have to do is oh, didn't work out. Never mind. In the end, these two have to be equal. They have to be equivalent, right? They have to be equivalent. Okay, they have to be equal. All right. Okay. So how do we do that? How can we make these things equivalent? All right. Now, this is the true concept over here. Now, we have to know that the present, we can do it two ways. Let's project this thing here to present value and this scenario here to present value. So both must have, let's call the left hand side P1 and the right hand side P2. All right? Okay? Both must have the same present values. So we have to calculate present values on the left hand side and the right hand side. We must calculate the present value on the, they have to stay equal. Both must be equal, right? So P1 must equal to P2. Another way of doing this problem is we find the future value in year 5 and both must be equal. So I'm going to do it this way, guys. I'm going to do it this way. All right, now let's now look at the left hand side. So in the end, we must say that, you know, for the purpose of this problem, P1 should equal to P2. Okay? For the purpose of this problem, P1 should equal to P2. All right, now that's what we're saying over here. Okay? All right. Now, how are we going to do that? Well, remember, can you tell me how can we bring these 5 repayments back into, how can we roll it back? How can we, these annuities, but the annuities are different levels. How can we bring it back, guys? Anyone got an idea? Anyone wants to make a suggestion? No? All right. Okay, so no suggestions, no buyers over here. Yes, we discount. Yeah, we discount, but discounting is used for future value. We're going to discount the annuity. So what happens, guys, is this. What happens, students, is we have, you see there's 2 annuities here, these 2 100s, and then there's another set of 300s, right? There's another set of 300s. Now, the catch about annuity is, if you want to roll back an annuity, what do we do? If you have a set of annuities, we just did the problem before, remember? We just did a problem early on, just before this, right? If you want to roll back an annuity, what do we get? What do we use? What formula do we use to roll back the annuity? Come on, we just used it in the early. P given A, right? What is the condition for A over there? P given A, that's correct. We have to use P given A, right? We have to use P given A, right? But what is the condition for A? What did I type over there earlier on in our earlier problem? When we were doing the problem with the TELS loan, the student loan scheme. A must remain constant. Yes, Luvkesh. Yes. A must remain constant. A must remain constant. Okay? Yes, Savnil. A must remain the same. Now, in this case, A is not the same, right? Now, the other condition for A is that when you roll back annuity into present value, it brings it to the period immediately before. It brings it to the period immediately before. So these two 100s will get rolled back to the period immediately before, and these three 300s will get rolled back. If you use P given A, it will roll back to that point, right? Then what are we going to do? Well, we've got to do, I mean, then from this point here, we've got to do a rollback, right? From that point, we've got to roll back. Okay, we've got to roll back to here as well, right? So let's now mark that up. Okay, so when we roll these two 100s, I'm going to call that P1A. All right, I'm going to call that P1A. All right, I'm going to call that P1A. These two 100s being rolled back, right, using P given A. And when I roll back this guy here to this point, that's going to be known as P1B. That's going to be known as P1B. All right, that's this thing here. All right, this point here. Let me see if that's P1B. Okay, now P1B has got to be rolled back to the first year as well. So that's P1C. All right, so that's P1C. I'm just giving different names. Okay, that's going to be called P1C. Okay, all right, let's do the left hand side and then we'll come back to the right hand side. All right, okay, we'll do the left hand side and we'll come back to the right hand side. Okay, let's forget about on the right hand side for now. Okay, let me just save this diagram. All right. I don't know why this thing is got to underline. Okay, there we go. Okay, we have to set P1 equals P2, right? We have to set P1 equals to P2. Now, let us now calculate P1. P1 equals to P1A plus P1C. Now, what is P1A equal to? For P1A, we've got to use P given A. All right, find P given A. Have I done that somewhere? Yes, P given A. We've got to use P given A. In order to find P1A, we've got to use P given A. All right. Now, so P1A will equal to, right, A, P given A. What is our A, guys? What is our A, by the way? Our A for those 2 years. Let's have a look over here. Remember, this P1A is from, where does the P1A come from? It comes from this first 2 batch of 100. So that is 100. And what is our I over here? Did an I of 12%. And what is the N? This is the catch. This is the catch. What do we get? N would be 2. All right. Now, P1A is equals to 100. Right. 12% is 0.12. 0.12. And the N value is 2. The N value is 2. All right. What do we get, guys? Answer? Answer, guys. Answer. What do we get for P1A? Is that 169 flat value? 169 rounded off to the nearest cent would be 0.01. Yeah? Okay. All right. Okay. Now, let's now look at P1B. What is P1B? We take these 3 batches of $300. We take these 3 batches of $300, right? And then what do? We roll it back to this point, right? We roll it back. Remember, whenever we use this formula, so I want you to note this down in your exercise book, right? Whenever we use this particular, we use this particular P given A formula, I want you to take note of this, guys. Very important point. You know, whenever we use P given A, right, it gives us the present value of the period immediately before the first period, right? So can you see over here, these two 100s, when we found the P, that was for the time immediately before, the period immediately before the first session. So these three by 300, when we find the present value, right, we will roll it back to the period number 2. All right. Now let's now look at P1B. Let's now calculate P1B. In order to calculate P1C, we've got to find P1B. All right. P1B, we are again going to use P given A, right? All right. P1A, P1B, right? Okay. P1B. Okay. What do we have here, guys? 12%. How many? What is the new N this time around? Can you tell me what is the new N? The value of N? It'll be 3. It'll be 3. And what? So let's now do the substitutions. P1B, right? The value is 300 over there. Okay, and the 12% stays the same. This becomes 3. This becomes 3. Right. Answer. Answer? What is your answer? What is your answer? Okay, somebody saying 2500, somebody saying 720. Okay, John, I'll trust you this time around. Okay, good. $720. We always round off to the nearest cent. So that's 2 decimal places, okay? Because remember, you don't have dollars and cents below 1 cent, okay? Now is the catch. Now is the catch. Now we want to find P1C. We want to find P1C, okay? We know the value, we know the future value is P1B, right? How do we find when we roll that back to present value? So if P1B is equal to, so you know, we want to find P given F, where where P1B is the future value, right? Okay, this is the catch here, guys. This is the catch. For P1C, don't worry so much about these guys over here. For P1C, we want to find P given F, whereby P1B is the future value. So how do we calculate that? What is P given F? How do we find P given F? Have we done P given F somewhere? Let me just scroll that up. P given F. Find P given F. P given F. Okay, so discounting. Basically, we're going to use discounting, right? Let me just copy that. Okay, so if future value is equal to that, then basically your present value, right? Your present value is equal to future value divided by 1 plus I to the power of n. 1 plus I to the power of n. Okay. Right. So what we're doing here, we're just discounting, guys. All we are doing is discounting. So basically we are discounting. Okay. Now what do we get? Okay. So the proper way to write it is, what is the proper way? What is the proper way to write this? Guys, what is the proper way to write this? We say that P1C, that was just the formula, guys. We say P1C is equal to, right? And we have to use P given F. P1C is equal to your future value, and to find P given F, right, at a rate of how many percent? At a rate of 12% for a period of how many years? Let's have a look at the diagram. How many years are we going to discount? 2, right? We're going to discount for 2 years. So what do we get? What is the future value over here? So the future value, let me just copy that just to give you an idea. The future value is P1B over here. Okay, P1B. All right, so what is our P1B over here, guys? So it was $720.55, and our interest rate is 0.12, and we bring it to discount it by how many years? We've got to discount it by 2 years, and I think some of our friends have answers. Very good. Our answer is $574.42. Okay, now that's not our final answer. So what was this? This was P1C. P1C. All right. Okay. Now, what can you tell me about the final P1? Our final P1 is basically equal to P1A plus P1C. So what do we get? What is our P1? Anyone? P1, what do we get for P1? P1A plus P1C. P1B is only done to calculate the value of P1C. All right. So 743. Let's see if that's correct. 169 plus, yeah, 743. All right. That's just one side of the problem. That's just one side of the problem. All right. Let's now do the other side of the problem. Right. And we have sort of run out of time. We've run out of time. Let's do the other side of the problem. But I'm going to just quickly try and comment on that. Same technique, guys. Same technique. Okay? Same technique. Right? It is exactly the same technique. Now, in this time here, we've got to calculate what our P2 will be. Right? How many minutes do we have, guys? Let me just check my Google time. All right, it's almost over. Let me just mention this so that you come prepared for the next class. We're going to roll back these two C's to period 0. These two C's, we roll it back to period 3 using P given A. And then from period 3, we roll it back to period 0 using P given F. Okay? All right. That's it for today because we've run out of time. You'll be hearing from us shortly for the week 9 lecture transcripts. There are no exemptions. Okay, that's it for this morning. Thank you for attending, and we'll see you on Monday. Goodbye.